Hey everybody, this is the video for the second part of lesson 7.1 on ratios and proportions. So you should have watched the 7.1a video already about how to set up and solve ratios. Now we're going to turn our attention to the proportions, remind you how we are supposed to solve those, and go from there. So this is where we left off after the first video. So find this place in your notes, get ready to write things down, and here we go. The essential understanding for this part, if two ratios are equivalent, which means the same value, so 2 out of 3, okay, the ratio 2 out of 3 is equivalent to the ratio 4 out of 6 because they both have the same numerical value, 0.666 repeating. If what you can do is you can write an equation stating that they're equal. If the equation contains a variable, you can solve the equation to find the value of the variable. So maybe I didn't know this was 6, and maybe now it's an x. Okay, in that situation, there's a certain way that we solve that. It's called cross multiplying. So an equation, like I have in red above, that states the two ratios are equal is called a proportion. So proportion is the vocab word for today. The first and last numbers in a proportion are called extremes. Okay, the two middle numbers are called the means, and that actually becomes important for one of the things that we'll do in a coming lesson. So the means. So we have means and we have extremes. The means are, like we just said here, the middle numbers in the ratio. Okay, and the extremes are the outside numbers. Okay, if it's a fraction, the extremes are the first number and the last number that you write. Okay, those are going to be our extremes. Okay, the means are the second and third numbers you write, so the middle ones. Okay, the ones furthest to the outside are called the extremes. The ones closest to the middle are called the means. Okay, and what happens here is something is always true if the proportion is a true proportion. Let me get this, there we go. In a proportion, the product of the extremes equals the product of the means. So this is how we can solve a proportion. We know that this is true right here. Okay? If we have a proportion, we know that A times D has to equal B times C. So if you multiply the proportions, that's equal to the product of the means. So one way that we look at this is we say we cross multiply to solve. So A times D has to equal B times C. Okay, in the example that we've been running with here, you see it again. Okay, 2 times 6 is 12. 3 times 4 is also 12. So what we have here is the 12 is going to end up equaling 12. Okay? Since that proportion is a true proportion, the product of the means equals the product of the extremes. Okay? So what you'll need to be able to do is solve proportions. You'll know maybe 3 of the 4 pieces. You have to find the last piece. So this first one, the extremes are 6 and 4. Okay, and I'm not going to label this every time. I'm just showing for your vocab purposes. This is a mean, and this is a mean. Okay, so those are going to be our means. Okay, and the blues are going to be our extremes. The way that we solve this is by cross multiplying them. So we know that 6 times 4. That's the first thing I would write. 6 times 4. Has to equal x times 5. I'm going to write it as 5 times x. Okay, so with this one, looks like we're headed for a decimal answer, and that's okay. 6 times 4 is 24. That's equal to 5x. We're solving this for x. We're going to divide both sides by 5 so that we can get cancellation there. Okay. So you could use, why don't we just use this as a decimal? This would be 4.8 equal to x. So x would have to be 4.8. Decimals are going to happen, not a problem. Okay? Let's do one that's a little bit trickier. Okay, our means and our extremes. Okay, we have multiple pieces that have a y in it. Okay, the extremes are y plus 4 and 3. Notice how I'm putting that in parentheses. So we have y plus 4 times 3 has to equal 9 times y, or 9y. Okay, this 3 has to be distributed into either piece here. So I have 3 times y gives me 3y. I have 3 times positive 4 gives me positive 12. That's going to be equal to 9y. So distributive property. Now I'm going to subtract 3y twice. So 1 on each side to cancel these 3 y's. I have 12 equal to 6y, and then I'm going to divide by 6, okay, to cancel these 6's. So y is equal to 12 over 6, which is 2. You can plug these back in to see if your answer makes sense. So let's do that. If I put a 2 right here and a 2 right here, what I end up with is 6 over 9 should equal 2 over 3. And you can just check, are those fractions really the same thing? And yes, the 6 over 9 reduces to 2 over 3. So we know we have that one correct. And why don't you take a second and solve these proportions first. The Edpuzzle will ask you what the answers are. So the video is gonna stop, solve these two, and then go from there. All right, so you should have tried to look at it already. You should know if you're correct at this point. So let's just take a look. We're looking at 9 times 14 equal to 2a. Okay, the extremes are 9 and 14. The means are 2 and a. So all I would need to do here, this is 126 equal to 2a. All I need to do is divide both sides by 2, giving me 63 for an answer for the first one. Okay, then the second one has that distributive step, so just make sure that you're careful with that. So we have 15 times m equal to 3 times m plus 1. Okay, distribute the 3. We have 15m equal to 3m plus 3. Subtract 3m from both sides. We get 12m equal to 3. Divide by 12. Okay, so this time we get a decimal answer or a reduced fraction. Maybe you put 0.25, or maybe you put 1 over 4. Okay. All right, moving on. So what the deal with proportions are is that the means multiplied always equals the extremes multiplied. So what that does, that allows us the freedom to kind of move some stuff around if possible, and still have a proportion that's true. So we have A, B, C, and D. None of these are going to equal 0 here. That's just up there so that we don't have a 0 on the bottom of the fraction. But here's 3 things that you can do to proportions and still have a true proportion. So this is just something for your notes. If you have a proportion here, okay, look what happens. A over B, C over D, okay, is equal to B over A equals D over C. So what they did is they wrote the reciprocal of each ratio. If you just flip the fractions, your proportion is still true. We just call this one property 1. Okay, so what you can do is you can flip the fractions, and sometimes the reason to do that is that we are able to maybe avoid some trickier math, some trickier algebra that goes with it. Okay, another thing you can do, just see what moved and what stayed the same. A over B, C over D. What they did is they wrote A over C, B over D. They switched the means. You can switch the means since those are the 2 that are getting multiplied anyways. It doesn't matter what order you write them in. Okay, again, maybe it makes things a little bit simpler if you write it that way. And then the third one, the property 3, we have look what they changed here, A over B, C over D. What they did is they added the bottom of the fraction to the top of the fraction. Okay, these are just algebra tricks that you can do, properties of proportions that always work. In each ratio, you can add the denominator to the numerator. Okay? And you can see as you work through these that you still have a true proportion all the way through. So what you can do is you can rewrite some of these proportions, and sometimes if you do that, you get something easier. So it says in the diagram, x over 6 equals y over 7. We don't even really need the picture for this, but that would be a true proportion in this situation. So this is the one that we have started with. Okay, what ratio completes the equivalent proportion? They're going from x over 6 equals y over 7, and they're turning it into x over y. They gave us that part right here. Okay, so x stayed in the same spot, but the y has moved down. Okay, which means if I'm moving the y down, the 6 is going to have to move. The 6 is going to move into y's spot. This is property 2. X over y should equal 6 over 7. Okay, so this would be the proportion that's equivalent. Still a true proportion that you could use to solve something. This is property number 2. Okay, we switched the means. So you can switch the middle numbers if you want in a proportion. Okay, same thing for the last couple here. It says for parts A and B, use the proportion, same one that we're looking at. This one, the thing that changed, so here's still the proportion we're working off of. They flipped the first fraction, 6 over x. Okay, x over 6 turned into 6 over x. So I'm going to flip the second fraction. It was y over 7. Now it's going to be 7 over y. This is property 1. Okay, property 1 says you can take the reciprocal of both. You can flip the fractions. Okay. Part B, okay, I'm just going to write it over here where I have a little bit more space. They added 7 to the top of the fraction. They left the y there, but they did y plus 7 over 7. So what they're doing is property 3. So what that means is we add the bottom of the fraction to the top. So this is x. X was already up there. We're adding 6. We're adding the denominator to the numerator. Okay, that would be what's missing there. This is property number 3. And maybe you do a couple properties consecutively. So part C has something. I'm going to go ahead and skip that one. It's not going to be something that's going to come into play for you. But you can do these consecutively and continue to change your fractions that way. Okay, so just be a little bit comfortable with those properties and what you're able to do. Okay, a couple of review questions to finish off. So to the nearest millimeter, a cell phone is 84 millimeters long and 46 millimeters wide. What is the ratio of the width to the length? So they're telling you the order that you're supposed to go with. The width was 46, okay, and the length was 84, okay, and the units are the same, so that was something we had to worry about yesterday, but the units are the same. So what we need to do is just make sure that this is simplified. It's definitely not simplified because we have even numbers here. So we could figure out what we could divide them both by. Let's start by dividing them by 2. Dividing this one by 2, 46, cut in half is 23. That will be 23 to 42. And at that point, we can't simplify anymore. So the first trick was making sure that you put them in the correct order. 42 to 23 would not be the same thing. Okay. And then this one, kind of silly, but it says 2 angle measures are in the ratio 5 to 9. That's the ratio that they give us. Write expressions for the 2 angle measures in terms of the variable x. So all they want us to do is take the 5 to 9 ratio and write it in terms of x. That just means put an x after it. That's all that means. And that's something that we maybe we would add those up to 180 if we knew they were supplementary or something like that. So that's all that one is. If it says to write it in terms of x, that just means put an x after it and be done. All right, that's it for today. So cross multiplying is the new trick, solving proportions by cross multiplying. You should be able to do the rest of the assignment. I believe it's numbers 13 through 31. Thanks for watching.